This is the last set of notes for this unit. We are still dealing with similar triangles and proportions. It's just two special theorems. The first one is called the triangle proportionality theorem. I don't like the way that this is worded, so I'm going to have us write something else. If two lines are parallel, then they create similar triangles. So I don't like this theorem. I don't like the way that it's worded. So here's what I mean. In the figure, if DE is parallel to AC, we've already seen this. This is nothing new. What that means is the little triangle is similar to the big triangle. So if the lines are parallel, then triangle BDE will be similar to triangle BAC. That is nothing new. You've seen it before. It's just written in terms of a theorem. So if we were to do this example right here, it says find the length of RQ. So I'm going to put an X there. Okay, so we know that triangle RQS is similar to the big triangle, which is triangle RUT. If I want to jump right to my proportions, I know the small side goes with the bigger side. So I have X, and then be careful, this one is X plus 9. On the other side, I have small triangle, big triangle. So 4 and 10. And again, you've seen this. Then we're going to cross multiply. So we get 10x is equal to, be careful here and make sure you actually distribute that 4. We get a 4x add 36. Some of you messed that up on the quiz. If I subtract the 4x, I get 6x is equal to 36. So x is 6. But be careful, we put the x in. It doesn't make sense to say x equals 6. So we're going to say RQ is equal to 6. We okay with that? Okay. Questions before you do one? Okay. I would like you to do this one, please. So take a minute, set this one up, and solve it. So I said we're comparing the small triangle to the big triangle. This is the small triangle, which has sides of 30 and 25. That's what goes here and here. And then we're looking at the whole triangle. Not just x plus 7, the whole side, which is x add 37. And then again, the big triangle, not just 15, the whole side, which is the 40. That's how we get x equals 11. Is it pretty safe to say that once you have a proportion set up, we can solve it? That it's just the setup really that we need some practice with? Any questions on that before we do a little bit more practice? Okay, next page. This page, I just want to talk about the setup because I think that you all are capable of solving most of these. Okay, find x. We are going to solve some of them, sorry, because they're a little bit different. This first one, find x. If we set it up, again, we are looking at small triangle. So this triangle first, which has sides of x. And then whatever this side is. Well, what is that side? 21, right? If the whole thing is 27, this is just 21. Then if we look at the big triangle, what is this side of the big triangle? 7 plus x, or x plus 7. And then this whole side of the red triangle is 27. And you guys can solve that just fine, right? Okay. Let's look at that one to the right. Determine the length of each segment. So I'm going to make some labels for these. I'm going to call BC X. FC I'm going to call Y. And GB I'm going to call Z. Okay, do we see that we have 3 different triangles going on here? Little, medium, big. Okay, so first thing that we're going to do is we are going to compare the little one to the medium sized one. So this is our little triangle, which has sides of 3, 3, and Z. If we compare that to the medium-sized triangle, which is this one right here, we have this side, which is 8. We have this side, which is 3 plus x. And we have the y. Okay. Y and Z we can't find right now. If you notice on the figure, they're both these little bases. We have nothing to compare them to until we get to this 20. So Y and Z we can't find right now. That's not going to be helpful. But we can find x. Can you tell without doing any multiplying right now what x is? 5. Right? If these are both 3, these both have to be 8. So if you cross multiplied, you would find BC or x to be 5. Okay, so that's what goes right here is 5. Now, if I go to find Z, let's say, for Z, that's part of the small triangle. I need to somehow, though, compare it to this 20 because that's the only base that I have. So I'm going to have to use the big triangle. The small triangle has sides of 3 and Z. So I'm looking here, 3 and Z. If I look at the big triangle now, this whole side is 18, and the base is 20. So that's how we would find Z. And we would do something similar for Y. Are you okay if I just leave us there? No, we want me to go through it? Okay. Cross multiply, we get 60 is equal to 18Z. I don't have a calculator out, so maybe somebody else does. Can somebody do 60 divided by 18 for me? What is it? 3.3. So that is my GB. Lastly, if we go to find Y, okay, so Y is going to have to be compared to this base again, which means I'm looking at the medium triangle and the big triangle. So Y on the medium triangle goes with 20 on the big triangle. And again, I'm looking at this side. So I get 8 on the medium triangle goes with 18 on the big one. And that's what we would cross multiply to find Y, or to find FC. You will have one like that in your homework. Okay, last two that I want to set up. Okay. The theorem also works the other way. It helps us determine if lines are parallel. So you'll notice in these last two examples, we don't actually have anything to solve for, right? There's no x. All you're doing is just setting up the same proportions that we did before. So small triangle to big triangle, so we get 11, and then add those two together is 26.4. And small to big, we get 10 to 24. All we care about is, are those two sides equal? I have no idea, so I'm going to have to do a little dividing. 11 divided by 26.4 gives us 0.416 repeating. So this is 0.416 repeating. And then 10 out of 24, same thing, 0.416 repeating. So determine if something is parallel. That's a yes or no question. So yes, MN is parallel to JL. Questions for me? Okay, we have one more theorem that we're going to talk about before our break. This theorem, it's the same idea. If you have parallel lines, this time we are comparing the small figure to the big figure. That's the only difference, is they're quadrilaterals this time instead of triangles. We're not even going to fill that out. We're just going to look at examples. Okay. Find the distance HF between Main Street and South Main Street. So find HF. This is what we're looking for. So we're going to call that X. Now, the reason we are told that these angles are congruent, they're corresponding angles, which makes these lines parallel. Which make these lines parallel. Okay, so again, we are comparing small, which in this case is this figure, to the whole thing, which is this figure. So if we start with the yellow figure, we have a side of 300, and then we don't know this side GH. So maybe instead of calling HF X, I'm going to change my mind. I don't want that to be X. I'm going to make this side my X, my HG. So that'll be my X. So then, if I go to the big blue figure, this whole side is X plus 120. And this whole side right here is 450. And that's the proportion that we're solving. Now, we are going to solve this one. I'm going to simplify this fraction on the right first, just to make my life a little easier. I can divide by 150. So then I get X over X plus 120 is equal to 2 over 3. It's just easier to cross multiply that way. Okay, so now if I cross multiply, I get 3x is equal to 2x add 240. So x is equal to 240. That's not our answer though. So we have one last step. We just found this distance right here. What is our actual answer? What? 360. We are finding the distance between Main Street and South Main Street. So again, this distance right here, got to add those two up. So 360 yards. Okay, I'm going to ask you individually to do one last problem, and then we will take a break before finishing the last theorem. So you are doing this problem right here by yourself. Find the value of x, please. If you can look to the board, I got an answer of 21. So again, we are comparing our smaller figure to the bigger figure. They're just not triangles in this case. So we are comparing this small figure to the whole thing. So x goes with the whole side of x plus 27. And then this little side you had to find. It wasn't the 18. It's the 14, and then the whole thing. Always smaller to bigger.
I didn't do it like that, but I got 21.
Okay. There is another way. It will work most of the time. Let me show you when it does work and when it doesn't. Okay. If this is going to confuse you, don't listen. Okay. So, Marin, I believe what you probably did is x over 27 is equal to 14 over 18.
No.
What did you do?
18 over 32 is equal to 27 over x plus 27.
Oh, great. I love that. Not even going to talk about the other way then. Yep, that works. Beautiful. Okay, we're going to take a break. We have one last theorem to talk about, and it is called the angle bisector theorem. What does it mean to bisect? To cut in half. Okay, so in our figure, what we're talking about is an angle that is cut in half. And when that happens, this triangle is similar to this one. This triangle is similar to this one. So these two parts go together, and those two parts go together. We're just going to do some examples. So go to the next page, please. Okay, so what I want you to notice is we have an angle bisector here, which means this part goes with this part, and then this part goes with this one. So if we start with the red, the left triangle has side of 7, and that corresponds to 13. Then if we go to blue, we have this that corresponds to x. Now the question is, what do I call this part right here? It's not 15. 15 is the entire quantity. So any idea what I would call that part that I circled and drew an arrow to? 15 minus x. Thank you, Paxton. 15 subtract x. 15 is the whole thing. We just want to subtract the little x. So we get 15 subtract x. And let's cross multiply. So we get 7x is equal to 195. Subtract 13x. So if we add 13x, we get 20x is equal to 195. So x then is 9.75. Or you guys know I like fractions better, 39 over 4. Questions or comments? Okay. Can you please complete this example? So here is my setup. So remember, this theorem is a little bit different. We're comparing this triangle to this one. So on the one side, 14 goes with 48. And then looking at a second pair of sides, 14 goes with x. And what I did just to make my life a little bit easier is 24 over 48 is just 1/2. So if you simplify that right away, it's a lot easier to get to x equals 28. One of the reasons I keep doing things without a calculator when I can is we are having a lot more conversations as math teachers about whether calculators should be allowed on everything. And there's actually quite a bit of research that shows the benefits of not using a calculator. So that might be something we start doing second semester, is not using calculators.
I did it differently, but I got the same answer. Is that okay to do it like that? Okay.
Okay. We have two last problems. Can you go down? Two things. I want to talk about this first problem. Segment MK is a bisector. Find the value of x. There's an issue here. Do you know what the issue with this problem is? What does bisector mean? Cut in half. What can you cut in half? What kind of items? Angles. What else? Segments. Do we know what MK is bisecting? No. So right now, can you write above that, segment MK is an angle bisector? Angle bisector. All I want is you to take 2 minutes and set the two up. Write a proportion for each. I don't want you to solve. I just want you to take the opportunity to set them both up, please. This is how I set both of them up. Your setup might be a little different, particularly on the first one. On the first one, look at the cross multiplying. As long as you end up with the same quantities being multiplied, then your setup will work. So as long as you end up with the same quantities being multiplied, your setup will work. And then on the second one, again, compare small to the whole thing.
What was the answer for the first one?
No idea. Did anybody solve it?
I got
17?
I got 5.
Maren?
How is it 2x plus 7?
I think it should be 27 is what I meant. Does that make more sense? Okay, thank you for pointing that out. How do we feel about this? Okay, I will tell you the ones on your homework are a little bit tougher because there will be some factoring involved. So just be aware of that.